Because like Lance says, what does it do?
Clunk, 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 as it goes over the pulleys, and it can get to you after an 8 or 10 hour day out here. Clunk, clunk.
And so what's really nice is giving me nice movement back and forth across the diamond wheel, but it's keeping the angle stationary.
Yeah, real highly precision. Hey, welcome back, and thanks for joining us for Shop Adventures number 13. Hi, I'm Lance. That's Patrick back behind the camera, but he's not staying back behind that camera today. He'll be coming around shortly to join me, but first I have to go over this week's topics, so let's get started, shall we? Okay, you'll see there's a box. That means we have viewer mail. Our first one, it's a big deal to us. We're real proud of it. It does come to us from the state of Arizona. I can say that much so far. You're going to open this with us. The next thing is we got our first fellow YouTuber shout out from Hopper1, link down below if you'd like to see. He's pretty good with us. He's been sharing some lessons for us and helping me back and forth. We get along really well. Real proud of our relationships. We're really excited to have friends on the YouTube channel, by the way. It means a lot to a couple people living in a rural desert. Okay, all that being said, let me go through the topics. Okay, this week we're going to cover, after this viewer mail, we're going to cover Pat's going to go through a demonstration on how to fuse the belt for the micro drill press. I'm going to get to share with you it running. It's not drilling anything today, it's just going to be showing it running. The next thing it's going to learn to do is make us some money, probably. But let's get started on that. Okay, so we're going to cover the drill press. Patrick's going to also share what is the difference in the watchmaker world when we rebuilt this Bergeon carbide tool sharpener. Now this is really cool because you're going to think, oh, tool sharpener, one of them big ones you pull with the type we had for the big machine shops. Well, this is for the watchmaking business, so get ready for a little exciting lesson on this little beauty. And it's pretty vintage as well. And then we're going to give you a little bit of an update on our Barker rebuild. We're going to share that we removed the bearing last week, and you knew that was quite a long video demonstration of how we wanted to tackle it, and we got some great feedback on that, by the way. I really appreciated it from everyone. Okay, I'm going to show you how the Barker base is going to start off, the frame, the forge, basically the main casting. And then we're going to share some vintage vices that go with it. They're perfectly matched in their size to the Barker mill. The Barker mill is a 6 1/4 by 20-inch bed table size. So we're going to give you a little lesson on that. Then we're gonna give you a little bit of an update right now on the on the Levin lathes, the 2 instrument lathes. You know, we've been off that track for a little bit. We're going to get back on that finally, but we're going to give you more of an update next week on that. But I will give you one hint. We're going to throw in a Levin and Son Company micro drill press. It goes with these pairs of lathes really well. Decided to go ahead and catch it in there. You're going to enjoy this. I hope you enjoy it. Hopefully do some good filming and share it, do it justice. And I think that's all I have. So Patrick, time to grab your chair and come over, I guess.
Okay.
Since this box came from Patrick, not me, by the way. Somebody saw this and decided. So he's opening this. I'm going to explain who's in it. I'm going to explain what it does. It is a product that powers a single channel chart recorder, and this device ran this pictured device at the University of Arizona, and this comes to us from a viewer that lives in Arizona with a good friend of his. They got together, worked really hard on this, and his name is Roy Parsons. He's a real nice friend. He's authorized me to tell him Pat's opened the box. He's probably anxious to open it because I know he knows what's inside. And as he opens it, he can go ahead, and I'm just going to read to you what it is.
Okay, feels like an early Christmas.
Jingle bells. This is a, we have that little Butane motors. This is a motor. We have those little Butane motors. We did the 1/8 horsepower, and then we got down to what actually is going to run the little micro drill press. It's a 1/15 horsepower. This little beauty right here next to us is a 1/75 horsepower. Did you know that fractional size horsepower motors were first developed and designed by the two brothers at the Butane Electric Company in Chicago, Illinois. So the Pat's unwrapping it. This did come in a kitty blanket. We do both have cats. They're indoor cats, so that they warned us that this was a cat blanket. It's perfectly fine. We love cats.
Oh yeah, look how cute
Look at this little motor. Oh.
And look, this has the little oil cap.
Oh, there's one on my side. Yeah, two.
Look, just like...
It's got oilers.
Wow, you know, and these, we thought... We don't see these very often. This is only the second one I've seen with the oil caps.
Ever.
You know, first being ours. Wow, so this is really nice.
Now this motor requires a step down gearing to operate these types of charts by minutes and seconds. And we're going to give you more details later. We're actually going to be we're going to refurbish this because this actually runs, by the way. So we're going to be refurbishing this. They are now mailing us the gearbox that goes on here. It's a 6 or 8 speed gearbox reducer to keep it under constant load. So it's just adorable. I don't have a use for it today. That doesn't stop us. Pat's going to add it to the Butane collection. Once it's rebuilt, we will be doing that rebuild on this YouTube channel, Shop Adventures, in the future when we have an open time that we have a gap or in some kind of things we're doing, maybe making manufacturing and what have you. So does that cover everything, Pat?
Yeah, and you know, this is did you mention it, the horsepower? It's a 1/75th horsepower motor.
Yeah, it's only 1,800 RPMs.
Yeah, and that's great.
It's beautiful. We're really proud of it.
Thank you so much.
That's really nice of you, Roy. Thank you. And your friend there. Both of you guys.
Yeah, we really appreciate it. Thank you. Okay,
shall we wander out in the shop now and get started on all of our little lessons and sharing today and show you some actual machines running for once? Even though they're not making parts yet, they are running. Or at least you're going to see a few today, and you're going to see some more next week. You're going to see a pair of brothers. We've always talked about one of these, but we're going to share two of them. Okay, come along and join us, will you? Thank you. Okay, as I promised, we're going to go ahead and we're back out in the workshop right now. Pat's going to show us how to fuse that belt. He's really good at it. He's going to give you the detailed, movement by movement details on how to do that. And this belt is actually the belt we're going to be running the micro drill press on, the German-made one, shortly. So hey, Patrick, why don't you go ahead and start with us?
Okay. Yeah, what I want to show is, okay, I've been doing this for many years, more than I want to admit. And I want to show you how I used to do it and kind of run you through, kind of the steps, why the process I used to use first, why it didn't work, and so forth. Okay. Okay, this is the belt we're going to use. As you probably saw in the prior video, this is the belt we're going to use in the micro drill press. Okay, and I've already marked it so it's ready to fuse. But before we move forward with that, I kind of want to show you the first method I used to use. I actually used to use an alcohol lamp just like this, probably this particular lamp. And how I used to do it is how they would recommend in many of the books I would read and how I was taught. You'll see that they tell you to hold it up right above the flame, the two ends. And so you want to hold them up till they melt a little bit, and then move it away from the flame and then hold them together so they fuse together. And I used to do this for many years, and the problem I had with it was over time they would start cracking. What I mean by crack is at the seam where it was fused, it would start separating and it would break. And I think the problem with this method is it's just so hard, holding these things over a flame, it's just so hard to get a consistent temperature on each end. And sometimes you don't get it hot enough so they don't fuse, they don't melt enough to give you a good fusion connection. And then other times you get too hot and it starts melting and it's just a disaster. So, but I did this for many years and that's what we lived with here. Oh, and then later, I forget, could have been a magazine publication, could have been a book, but they were showing to use a knife. This would be like a butter knife, or this is kind of like the knife I would use. And then I used this method for a number of years. And what I would do is I would stick this knife in a vise like this. I'm just using this for demonstration purposes, but you can use any vise you have laying around. Okay, and what I would do is make sure your knife's secured. I would take the alcohol lamp, light it, and then just heat up the knife. And again, this is kind of difficult. You know, how hot do you heat it up? You know, you just have to, it's just trial and error. So I'll heat it up, you know, at a temperature I would think would work. Sometimes I would just leave the lamp like that, very carefully, not burning myself. Okay, and then I would get two ends of the belt, and then on each side of the blade, I would just like this, let the surface melt the belt ends, and then when I feel the ends melting, immediately just go straight up and connect the two ends and then let it cool. Okay, and this method actually worked much better than the prior method, because in this case we have a consistent temperature on the blade, so each end of this blade is the same temperature. So we're actually heating both ends of the belt at the exact same temperature, which is just almost impossible, you know, doing it over the flame. And I also found it a lot easier to get a consistent melt, you know, on the surface rather than on an open flame. Okay, so you know, again, did that a number of years, and then just one day, you know, Lance had wanted me to melt a belt for him, or
Yeah,
fuse a
because
belt.
remember, I don't melt the belts because I got tired of them flying off and hitting me. That's got a real special knack for patience with this. So he does all of this, and I've actually never seen him do something he's going to do in a little bit, so I'm excited about it.
Okay, yeah, so an idea came to me is, you know, this is a butane soldering iron. And usually when you buy these in a kit, and they're really cheap now, you want to buy these in a kit because a kit comes with a lot of different attachments. You know, obviously they'll give you the soldering attachment, which is like a probe, and then they'll give you this attachment, which I think is called the knife attachment. See, and you can see it's like a little knife, you know, not sharp, it's not sharp, but it's exactly what I just thought, wow, you know, this would be the perfect thing to use to fuse our belts, because, you know, instead of, you know, using the alcohol lamp, here I can dial in the temperature and make a note, you know, after trial and error, I can pretty much determine what works for us. And it'll be such a faster process. You know, we get a consistent temperature that we can dial in every time. So, and that's what I think I've been using for about 5-6 years. And I tell you, ever since I've been using this method, it's fast and we get consistent, great belt fusions, or whatever you want to call it. So let me show you. Let's give it a try. Okay, first what we're going to do, let's turn on this. Okay, so we can let it heat up for a little bit. Okay, and just like the knife, as you see, I'm using the vise to hold it very securely. We don't want this to drop. Okay, but it's in there pretty secure. Okay, and it's about right there, a little over 50%. I use, with this particular soldering iron, I usually go about 60-65% right there. Okay, now we take the belt. Okay, the belt, I've already marked the length. If I can find it. Maybe it's at the other end. Do you see it, Lance? Oh, there it is.
Aha!
Okay, really important here is you want to be sure when you cut these belts that it's perfectly straight. You know, you don't want an angle. It's going to really make it more difficult to fuse the two ends. Okay. Okay, so here's our belt. Looks kind of small, but okay, I think we're ready. It looks pretty hot. Okay, and you can test it any time. You know, what I do is I just touch it very slightly. Okay, and it should feel really slippery. Okay, I could feel it. If it's not slippery, then just let it heat up a little
I
bit
see
more.
smoke rising there.
Yeah, see that? I may have it lit a tad too hot. But see, that's nice. As you can see, if it's too hot, I can dial it in a little bit. You know, unlike an alcohol lamp. Okay, so let's give it another try. So you want to heat them up both at the same time. See it melt? Just go straight up. I blow on it to cool. Okay, and don't worry. See how it beads up like that? Don't worry about that. We aren't worried about the cosmetics of this belt right now. We actually want that. We want both ends to melt very well because, you know, we want that strong bonds. We want that material to melt together. You know, we don't want just the heat of the surfaces to make it stick. We want it to heat thoroughly. Okay.
So you have a way to clean that up then, so it's not going to go around the pulleys, ba-bum, ba-bum, ba-bum.
Okay, yeah. See, it cools off pretty quick. Okay, I think I got this a little crooked.
Okay, hey, we're back with Patrick right now. He wants to give us a much more detailed update on the fusing of the belts that are going to go on the micro drill press, and just has a little finite detail to share with us. So let's get back to him. Hi, Patrick.
Yeah, hi. I just wanted to share one thing before we put this belt on. Okay, as you can see, I have a successful fused belt right now. It's straight. But you'll notice, if you look really closely, there's a really big bead I was talking about, which is a good thing. This isn't a bad thing. You want that because that tells us, you know, that both ends melted very thoroughly and we have a good weld right there. Okay, but one of the things I wanted to show was if the bead's really big like that, one of the things that really works well is a flush wire cutter, just like this. Okay. Do you have a good focus lens?
I sure do. I got
Okay, perfect.
I showed that bead really well there.
Yeah, and see, with this, you can just go around.
Well, that looks a lot easier and safer than that razor blade to get started anyway.
Yeah, just to get started. You know, see how easy that is? Yeah, and I want to show that because it makes the job a lot easier. See? Let me bring it back. See, now it looks a lot better. Okay, but we still want to go over to the block. And we just want to give it this is just giving it a nice finished touch. You know, we want it to be really smooth. Because like Lance says, what does it do?
Clunk, 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 as it goes over the pulleys, and it could get to you after an 8 or 10 hour day out here. Clunk, 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 clunk.
Okay, and that's about it. Let me go ahead and finish this up, and we'll be right back.
Oh, that sounds fantastic. Be right back with you. And we're back with Patrick, and he's going to install that fancy little belt he's fused now, and it's just beautiful looking. Here we go.
Okay, which is done really quick. Okay, there it is. So you got a nice, good, smooth belt.
Oh, it's like invisible.
Okay, let's go ahead and install this. Okay, here, let me do it we'll do it like this. Whoops. Okay, let me just set that like that.
Here comes your hand, Santa's helper.
We got a machine, a little handle right there. Okay, got that?
Yeah, I got it for you.
Okay. Go down. Down. Okay, I got it now.
Got it?
Yeah.
All right.
Just want to make sure I got it parallel. Okay, I got good tension right there. I think that's good.
I think I'm going to come around the other side and let you do the operating. So you're going to show. There we go. Let's see if we can do this. Yeah, I want to come in at like an operator here. So you can see Patrick operate this thing, and he was going to use the foot pedal and what have you.
Okay, before I forget, we want to make sure we oil the spindle. Okay, we just want to put a couple of drops.
Those little oilers. With their temporary plugs.
Yes, especially this is our first time running this, so we want to make sure it's well oiled. Okay, actually I got to tighten the motor. Okay, what I can do is I can go ahead and fast forward this. Yeah, that's good.
Hey, I'm gonna switch. All right, you're gonna go in round behind me. Okay. Let's see if he knows how to operate this machine here.
Okay. So you can see it works. Okay, feels good.
Nice and
Just
smooth.
yeah, before we turn it on, we just want to make sure everything feels good. Okay, the belt feels good. Okay, let's go ahead and give it a shot. There we go. Okay, so we could for the video this is fine, but we just need to tighten these collars because what you're hearing is these wheels going back and
Oh,
forth.
yeah, little chatter.
Yeah, but once we tighten these up, it should be really quiet. But there we are.
And then down below Pat's foot is a foot pedal for this.
Oh yeah, here, want to show them the little foot
Oh
pedal?
yeah, here we go. What do we have there? Yeah, see, this way your hands are completely free at all times, totally able to operate this thing, and just have hands-free control, just total control. Love it.
Yeah, and right now the reason why we can't show you guys it actually drilling is because we actually have to fix our drawbar. We have a little slight problem with it because this uses 8mm collets, and so if this was working, this goes right here, and then you put the collet on the bottom, tighten it up, and then that would hold your drill bit.
Oh yeah.
See, just like that. Okay, and I think we may be making a new one of these because this one the condition's a little iffy.
It's got a few miles on it.
Yeah.
Yeah.
So, but we're gonna get this done, and we'll be able to demonstrate it for you guys. I'm actually drilling.
Yeah, we'll just get that off camera. It'll be done and over with, and we'll be back making a real part with it.
Yeah.
All right. Well, that was great, Pat. Thank you. Okay, we're back with Patrick, and you know why? He's going to show us another darling little machine that's going to be running for us today. And first, he wants to give you a little bit of a show. So, hey, Patrick.
Hi. Great. Yeah. Before I show you that, what I'm actually going to show you is a Bergeon Carbide tool sharpener just for watchmakers. And it's a really unique little machine that I've never seen one before when I acquired this, so it's a really unique little device. But before I show you that, what I want to do is I want our viewers to get a good perspective of the little tiny tools we use. I'm not sure, because a lot of times in the past videos you've seen from us, we've used a bigger lathe, a medium-sized lathe, and the tools are much larger. So what I want to do is I want to kind of compare them for you, just so that you have a good overview and a good perspective of how small the watchmaker tools really are when you compare them. Okay, what we have here, this is a tool post and a tool post holder for one of our larger lathes in our machine shop. Not in this workshop, it's in our other shop out on the other side. And that lathe is they call it an 11 by 27 inch lathe. And what that means is it has an 11-inch swing. Okay, that's the diameter of the part that you can chuck up and you can turn. And a 27-inch means the length of the part that you can chuck up into the lathe with the tailstock. Okay, so what we have here is this model of tool post is an AXA. Okay, they recommend this use on a lathe with a swing of 8-inch to 12-inch. So it's a perfect fit for our 11-inch swing lathe. Okay, and in this family, they make an AXA, BXA, CXA, and a DXA. This is actually the smallest version in the family, so it's a perfect setup for our lathe. And we currently, just give you a good perspective, this is a 5/16 inch tool bit. Uses carbide inserts, and you can actually use up to 1/2 inch tool blanks in this. Okay, now put this one aside. Okay, in here we actually have a little, it's not a watchmaker lathe, it's a little larger lathe over here. Okay, this is actually a 5.5 inch by 10 inch lathe. So that means it has a 5.5 inch swing, and then they can hold a 10 inch length part. Okay, obviously this tool post is way too big. So it uses a tool holder or tool post and holder that's a little smaller. Actually, this size is actually 60% the size of this. And they call this, the size of this is designated as 0XA. And it's a special size. This size became very popular with all the mini lathes that came out many years ago. You'll probably be familiar with the 7x10 or 7x12 inch mini lathes. A lot of places carried them. They're really popular with the home shops. And so that's how this size became very popular in that area.
Smaller.
Yeah, it's a lot smaller, huh?
Yeah.
Okay, and here we have a 1/4 inch bit. I forget the maximum size here. I believe this can also do almost 1/2 inch, but that would be ridiculous. You know, for the size of lathe, a 1/4 inch is really sufficient. Maybe 5/16 is the largest I would go with this holder in the lathe. Okay, now for the last one, I'm going to show you the tool post that we use for our watchmaker lathes. And this is what we use almost daily. You know, we only use this occasionally, which you've seen on the videos, but soon, once you see more of our capabilities on the watchmaker lathes and the instrument lathes, you're going to see us use sizes like this.
Oh.
And see, it is much smaller.
It's
Here.
just a little tiny.
So as you can see, it's a lot smaller. And and just comparing the tool bits, it's just cute. And the size of this tool is actually 1/8 inch. And that's what we use all the time for the holder. And we actually have a few styles. This is just one. I chose this because it's very similar in design with these two. And this is actually made by Bergeon right here in the USA. Unfortunately, they haven't made this for about, I think, about 6 to 8 years, just because lack of demand, in our industry. So, but fortunately, we have a few of these sets, and we also have some other sets. We have a little set by KDK, and another set by many of our European users will recognize the Trypan, I believe how you pronounce it. And you'll definitely be seeing a lot of this, a lot more of the watchmaker and the instrument lathe stuff, and later in our videos.
Oh, as we get ready to start making our product, we're going to use all these different tools to make them, of course. Yeah.
So okay,
That's neat.
So hopefully that gives you a good perspective. But what we're going to do now is we're going to go ahead over to one of our watchmaker lathes, and we'll continue.
Okay, we're back with Patrick. He's going to share us some knowledge here and a little machine at the same time.
Yes, hi. Okay, we're back, and we're here at our little watchmaker lathe. And this was made by Marshall. It was made in the USA. We imagine a guy in the 40s or 50s, quite a long time ago. And why we're here, because I want to show you first, these are hand gravers that we use, carbide hand gravers. If you notice, just a few examples, different size bits.
Oh, the hand helps out. There you go.
Yeah, and they have your common diamond, shape. Okay. And these are actually hand gravers, and we turn using this method a lot. And what I mean by hand turning is it's where you chuck up a part. You use this hand rest, or also known as tool rest, and you'll position this really close to the part, and then just by hand you'll actually cut the part just like this. And we'll demonstrate it in future videos, but some users may not be familiar with this method. Okay, so that's what hand turning is, and that's what we use carbide a lot, especially with when we're turning blue steel. And in the beginning, when we used to have to sharpen carbide, we used to do it right here on the lathe, just like this. And what we would use an arbor with just a diamond wheel attached. So we would just chuck it up like this. Okay, we would use a tool rest. Okay, what I would do is just like position it just like this in front of the diamond wheel. And then what you'd always want to do is, before you use this, it's really important to just take a cotton swab, dip it in kerosene, and just, you just want to turn the lathe very slowly like this, and then just give it a little coat of kerosene, and that just lubricates it just enough so you don't mess up this wheel. And to sharpen this, let's say I want to sharpen this, let's say it has a chipped edge or just needs a sharper edge. You basically just use a tool rest or hand rest right here, and just like this. I don't want to ruin this bit, but this is exactly how we would do it, and it works great. And the problem though is we were really always concerned about doing any type of sharpening on the lathe, because being high-speed steel carbide, we just hate the idea of sharpening, doing any type of grinding on these nice lathes. So that's why I'm going to introduce this. We actually acquired this guy many years ago, probably about 12, 13 years ago. And we actually acquired it from a German watchmaker in Germany. And when we acquired it, this is what it looked like. As you can see, it was well used. I think it was more storage because the wheel was in great shape and it was fully functional. We used it for many years in this condition. Some other views.
Oh, look, another tool that came with no rubber feet on it.
Yeah, when we.
Oh boy.
And sadly, we used it like this without the rubber feet. So it had a tendency to walk, and we put on.
Yeah, we had to sit on a towel for running around so it wouldn't run around so much.
Exactly, but it worked. It worked for guy. It works really well. And as you can see, since we're restoring other machine tools and equipment around here, we decided, you know what, it's time to give this guy a little facelift. So we kind of wanted to share this, and it looks a lot better. It looks just like new. And what's really unique about this is you'll notice this diamond wheel right here has two surfaces, one in the front and one in the rear. Okay, right now this is the fine surface, but what you can do is just loosen the screw in the front, and then you can pull this, turn it, and the other side has a medium grit. So if you want to do some shaping, you would use the medium grit, and then if you want to do your finish, put that mirror sharp edge on the tool, then you would use this fine surface.
Can we show off its rubber feet?
Oh, sure.
Stay permanent there.
Oh, no.
You got it?
It can move. See,
see, that's how little tabletop machines are supposed to be. They're supposed to have those little rubber goodies on the bottom.
See, and now it won't move. And here I'll turn it on just to show that it's fully functional. And it sounds great. It's smooth. We also put new ball bearings in. And it's very safe. I can actually slow this motor down with just one finger. So it's perfect. If you get your bit caught or whatever, the motor will instantly stop. But it's strong enough that when you're sharpening a carbide tool, it doesn't slow down at all. So it has plenty of power for that, but it's not dangerous. So it's perfect. We love it. Now we don't have to touch a watchmaker lathe anymore when we want to sharpen carbide. So it's been really wonderful. But, the other thing I want to share though is we've had this for a while. It was made by Levin, and this hasn't been made for years as well, like so many other things. But this was Levin's. This is a carbide tool bit sharpener or fixture, and it's a really unique little device that I've never seen from any other manufacturer. And I'm going to show you how it's used. Okay, so basically we just pull this handrest off. Okay, and this separates in two pieces. Okay, I'll explain in a bit what this is for. We basically want to tighten it so it's straight up. I think that's good. Okay, then let's get our tool bit. Okay, I think that's right. Okay, and this slides right in this little pivot. Okay, and this is what's really nice. You can see what we can do is we can set this to the angle we want this bit shape to. So let's say we want it this angle. Okay, we'll just tighten it. Okay. Now we just slide this on and see. I actually have to move it closer. But just give you an idea. See now, if this was touching, I don't want to touch it, but see you would basically just go back and forth. And so what's really nice is giving me nice movement back and forth across the diamond wheel, but it's keeping the angle stationary.
Yeah, real highly precision.
Yeah,
on the
so
grind.
it's
can tell
highly,
the difference.
Exactly, it's highly precision, and this is nice if you want to, especially on a new tool bit. This is when we use it. Is when we buy new tool bits. Usually they don't have any type of shape or profile on them. So this is what's really nice. This allows us to get that profile really quick, and then once it has that profile or shape, anytime it needs any maintenance, the maintenance is especially carbide, sometimes you'll get the occasional little chips because carbide is really brittle and hard, or it just gets dull. And so the maintenance is really easy. You can just do it by hand. And there's actually a little rest right here. You can just, do it completely freehand, or use this little rest, see, and use it to help you, position and keep it still, and just go across the wheel like that. I hope that gives you a good example of all the tools we have, and then the benefit of having a dedicated sharpener.
Well, that's a lot of great choices to how to sharpen your little mini carbide bits. It's pretty neat. Thanks, Patrick.
You're welcome. Okay, Lance, what are you up to?
Uh-oh. As promised in our opening topics, I described that we're going to start rebuilding this Barker mill. Now, we removed the bearing from the pulley and all that kind of thing in the last video. And I want to describe the vices we're going to use. This particular machine, this is our Barker base. This is the column. It's already all painted, primed, prepped. The whole shebang's been done to it, and the finishing's correct. It's all been tested, and everything's sure for the ways are correct. Everything's so forth. Okay, we're not going to get into that now because we're going to get into the thousands of pieces that make up this machine and its factory secret attachment that I don't want to torment you with. It is a really unique attachment. The factory has no records of it other than they know they did make them. Okay, here we go. This has a pair of very specific vices. These are new old stock. They're made by the American Sun Incorporated that's no longer in business. They were in, I believe it says here, Aston, Pennsylvania. We refurbished these to this point, and this is what happened. These vices, the big vise that Patrick's showing you there, that big vise isn't actually for the Barker. It's just part of the family of the 3 vices we were able to score. They came basically bathed in cosmoline. And if you think that cosmoline wasn't a big issue to take these apart and even to just get the Allen heads out of the holes, just to be able to get the socket screws out, we had to clear the holes just to unbolt it, to disassemble this thing 100%. But there was something even worse. You know that bubble wrap that you see wrapped in packaging? You know how cosmoline should be wrapped in an oil paper? Well, these came wrapped in bubble wrap, and it's probably been on there a good 20 years. It's incredible. So we went ahead and took them. You can see from Pat's footage, he totally refurbished them. They are a pair of perfect vices. They will be used on this Barker mill. It's proportionally correct at size. And we just wanted to introduce you to it. And it's sitting on a beautiful 2 1/4 inch thick maple top table with a solid steel base bottom and a solid steel top. So this is quite a strong machine. Pat customized these bushings. Maybe I can get him to zoom in. These are customized sleeve bushings for holding what they call tool shank bolts. What do you call those bolts?
Shoulder bolt.
Shoulder bolts. Yeah, but they're perfect. But boy, were they a pain to get a line to get through the steel plate below there. But it makes sure it's strong as you can get it. We're real proud of this mill. We can't wait to start up building it in the new year. And the thousands of parts that make it up are going to come together to one beautiful machine that's going to help us do all of our roughing around here, because we can't do roughing on these little micro machines to get started for building our products. So thank you. Hey, we hope you enjoyed this week's video, and please don't hesitate to subscribe. And did you know we really do value getting those comments? We love to answer any question you may have for us. Thank you.